Hello everyone, welcome to Math World. This video is to discuss Cambridge International A-Level Mathematics Paper 3, which is the pure Mathematics 3 for February-March 2019, and the code is 9709/32. So let's move on to question number 1. Okay, so for question number 1, first part, show that the equation log x minus 4 with base 10 equals to 2 minus log x with base 10 can be written as a quadratic equation in x. Okay, so log x minus 4 equals to 2 minus log x. Okay, so now from here, I can just group the log together, right? So that means this will be log 10x minus 4 plus log 10x equals to 2. Now we have a formula here. Log A plus log B, it will be log A times B. Therefore, from here, I will be getting log 10x minus 4 multiplied with x equals to 2. Now, from this log form, we can change to index form, which is another formula. Log AB equals to x. This means the A is a base, the x is the index. So it becomes A power x equals to B. So therefore, from here, I will be getting log, no more log, the base is 10, the index is 2, and then the result is x times x minus 4 times x. Okay, so from here, I will be getting 100 equals to just do multiplication. It will be x squared minus 4x. So move this to the other side to get a quadratic equation. Okay, this is the first way. The second way is or. Okay, or I will just change the 2 into log. Because we have a formula here, log A is 1. Therefore, the 2 I can change to log 10 with base 10. This is going to be 2 log 10 with base 10, then minus log x with base 10. Okay, so then now here we need to apply another formula, that is log with any base a power b, it will be b log a. So the 2 will be moved up because that is the b log a form. That means now here I will be getting log 10 x minus 4 equals to log 10 squared minus log 10x. So when this is minus, we have another formula this side. So log a minus log b equals to log a over b. Okay, so I'm going to apply this formula now. That is going to be log 10x minus 4 equals to log 10 squared over x. So since you are getting log both sides, that means you can just ignore the log. Then I will get x minus 4 equals to 10 squared is 100 over x. So the x move up to the other side. There will be x times x minus 4 equals to 100. That is same step as this, right? So now just do expansion and move the 100 to the left side. So I will be getting x squared minus 4x minus 100 equals to 0. So we have two methods to show this quadratic equation. Okay, now part 2, hence means use the previous answer. Solve the equation, exactly the same equation, giving your answer equal to 3 significant figures. Okay, so now x squared minus 4x minus 100 equals to 0. So then this quadratic equation I will solve using quadratic formula. So quadratic formula is basically to solve this general quadratic equation. And then the x is going to be minus b plus minus square root of b squared minus 4ac over 2a. So it means that now I have to list down all the coefficients. A is 1, B is minus 4, C is minus 100. Then my x is going to be minus b, which is minus 4, plus minus square root of minus 4, minus 4a, then the c is negative 100. After that, over 2 times 1. Then from here, this is going to be 4 plus minus square root of 416 over 2. And now it's mentioned that 3 significant figures. So now first of all, we calculate using the negative value. That is going to be negative 8.198, and followed by using the plus value, the plus sign, that is going to be 12.198. And now I mentioned 3 significant figures. That is going to be negative 8.20 and 12.2. But then now, look at the question here. Okay, log x. So we know that the x must be positive. Alright, so x must be positive. Probably I will just write log 10x is defined for all x greater than 0. Okay, therefore hence your solution x is 12.2. So that's the explanation. Okay, question number 2. The sequence of values given by the iterative formula with initial value x1 equals to 2 converges to alpha. Use the formula to calculate alpha, correct to 4 decimal places. Give the results of each iteration to 6 decimal places. And now the initial value is given x1. So I will rewrite the question, the formula. So x1 is 2. Therefore, my x2 is going to be 2x1 power 6. So replace the x1 by 2 plus 12 times 2 over 3 times 2 power 5, then plus 8. And now the answer, the iteration 6 decimal places. This is going to be 1.461538. Now from 2 drop to 1.46, right? Therefore now we need to continue x3. So now my x3 is going to be 2 of the x2. Just rewrite all the values. Plus 12 of x2 over 3x degree 5. Then plus 8. And this is going to be 1.32263. Okay, so now look at here. The answer to 4 decimal places, we should get the same 4 decimal places. So obviously they are not the same, therefore we need to continue for the next calculation. So x4. So just replace the x by x4. Okay, then this is going to be 1.319508. There's your x4. Okay, so now again they are not the same. Then now just continue for our next calculation, x5. Then this is going to be 1.319508. Okay, so when you compare 3195, 3195, so therefore I'm getting the final answer. So it means that now my final answer is basically 1.3159 because the next value that is 0. So we can just ignore that to get the final answer. Now part 2, state an equation satisfied by alpha and hence find the exact value of alpha. So the equation, very simple, just refer back to this formula and ignore all the subscripts. Okay, so I will ignore the subscripts, then you will get x equals to 2x degree 6 plus 12x over 3x degree 5 plus 8. So to get equation, you have to move up the denominator and combine with the x on the left side. So it will be x bracket 3x degree 5 plus 8 equals to 2x degree 6 plus 12x. Okay, then from here you can just write the simplify. Okay, so now for left hand side, do expansion first. So which means your equation is going to be x6 then minus 4x. This is your equation. Okay, and hence find the exact value of alpha. So when you solve this, the exact value, right? So we will factorize the common term. So the common term is the x. Then you get x degree 5 minus 4 equals to 0. So now from here, the multiplication of two terms equals to 0 means that either first term 0 or second term is 0. Which means now first term is 0, we have found the solution. Second term is 0, x degree 5 is 4. Therefore your x is 5th root of 4. Okay, now you see value of alpha, and then go back to the previous part. So from here we know that it will be converges to alpha, and then we substitute, we start with 2. Okay, so then from here when you look at the formula, basically when you replace the x by 0, right? So here 0, 0, then the x equals to 0, means that there's no solution because we know that this is satisfied by alpha, means that you need to get one value. Since we have found this value, therefore I will just write x is 5th root of 4. Okay, so the x equals to 0 is not acceptable. Okay, done for second part. Now, question 3, first part, show that sine theta plus 45 degrees plus 2 cos theta plus 60 degrees is 3 cos theta. Find the exact value of tangent theta in the form involving surds. You need not simplify your answer. Okay, now for sine theta plus 45 degrees plus 2 cos theta plus 60 degrees equals to 3 cos theta. Now, here, sine A plus B, that is sine A cos B plus cos A sine B. Then the other one, cos A plus B, it will be cos A cos B minus sine A sine B. So this is going to be sine theta cos 45 degrees plus cos theta sine 45 degrees. Okay, that is for the sine theta plus 45 degrees. And then for the cos, you will be getting cos theta cos 60 degrees minus sine theta sine 60 degrees. Then equals to 3 cos theta. Now, cos 45 degrees, right, is basically, you can write 1 over square root 2 cos 45 same as sine 45 equals to 1 over square root 2, or you can just write square root 2 over 2. It's up to you. Okay, then now from here I will just write square root 2 over 2. So which means cos 45 degrees I will rewrite first square root 2 over 2, then followed by sine theta. After that, sine 45 degrees is square root 2 over 2, then followed by cos theta. plus 2 times cos 60 degrees is half. Then cos theta minus sin 60 degrees will be square root 3 over 2 sin theta, then equals to 3 cos theta. Okay, so now the next step is going to be multiplying these two. So 2 times half is basically 1. That means the denominator will be cancelled off. And then I will open the brackets and simplify, or probably I rewrite first. So when you open the brackets, the first two terms just rewrite. Then the next term is going to be plus cos theta, and then it will be minus square root 3 sin theta. So the cos theta on the other side, you can just keep it, because now we need to get tangent theta. We know that tangent theta is basically sin theta over cos theta. Okay, so I will group the sin theta one side and the cos theta the other side. So from here, the sin theta will be on the left side, and at the same time I will factorize the sin theta. So when you refer to the terms on the left hand side, this is sin theta, here is also sin theta, just group them together. And now here is going to be square root 2 over 2 minus square root 3. Now for the right hand side, okay, you will be getting extra 2 terms because you are moving these 2 terms to the left hand side. So I will be getting cos theta, initially was 3, then minus root 2 over 2, and the plus cos theta from the left side, when you move, it will be minus 1. Okay, so now I will get the same denominator for left and right side. That means it's over 2. So from here, I will be getting sin theta multiplied with over 2. So square root 2 minus 2 square root 3, because you multiply the square root 3 by 2 over 2. Then for the right side, get the over 2, right, for all the terms. But then before that, I will simplify the first and last term. So 3 minus 1 is going to be 2. So I will get 2 times 2, that is 4 minus square root 2. And now I will just use this concept. Tangent theta is sin theta over cos theta, which means I divide the whole equation by cos theta, or probably you can say this cos theta on the right side move to the left side. Okay, so then from here, before that, I notice that both sides also over 2, so the over 2 can be cancelled off, which means very simple now. The cos theta move to the right side, to the left side, and then this numerator move to right side, becomes divide. So which means now I will be getting sin theta over cos theta. Then equals to 4 minus square root 2 over square root 2 minus 2 square root 3. Okay, so now to get the simplest form, right, involving surds. So now here you can just simplify, or you need not simplify your answer. So if need not simplify your answer, probably, okay, now you can just leave your answer in this form. Okay, done for this part. Now, part 2, hence solve the equation. So now the equation is exactly the same as previous. Okay, no difference. Therefore, I will just solving this question. Oh, sorry. I should have written the sin theta over cos theta as tangent theta as the final answer. Okay, now hence means that I copy back the previous question. So that is tangent theta equals to 4 minus root 2 over square root 2 minus 2 root 3. And now you need to solve from 0 to 360 degrees. So this value is going to be negative 1.2614. Then now my basic angle is inverse tangent 1.2614. That is going to be 51.6 degrees. Okay, now draw the quadrant diagram. Because it's tangent negative, right? Negative for tangent, the value, the angle will be in second and fourth quadrant. So label these two values as 51.6 degrees. Now my first angle, it will be in the second quadrant, and my second angle is in the fourth quadrant. So then from here, I will just write my theta is second quadrant means 180 minus the value. And then if this is in the fourth quadrant, it will be 360 degrees minus the value. So at last, you will be getting 128.4 degrees and 308.4 degrees. So that's all for the part 2. Question number 4. Show the integration is 2 minus ln 4. So integrate 1 to 4 x power negative 3 over 2 ln x dx. So to solve this integration, since it is the product of two different functions, right? The first is algebraic, the second is ln x. Therefore, we are going to use the integration by parts. So integration by parts is integrate u v prime dx equals to uv minus integrate v u prime dx. So if with limits, just add on the limits. Alright, so now the u is ln x because we can differentiate ln x, but we cannot integrate ln x. So my u is ln x. Therefore my u prime, when you differentiate ln x, d over dx ln fx, that is going to be over fx, and then the numerator is f prime x. That means now here I will get over x, because whatever after ln, you just copy. So copy the x, differentiate x is 1. And then our v prime is x power negative 3 over 2. So then for the v, right, so integrate x degree n dx, it will be x degree n plus 1 over n plus 1, then plus c. That is your integration, provided the n is not minus 1. So from here, I will be getting v equals to x power negative 3 over 2 plus 1 is negative half. Then over negative half. So at last, you will be getting negative 2 over square root 2. Because the x power negative half means over square root x, not square root 2, square root x. Alright, so now substitute into this formula. This is going to be uv, so ln x times this value. So I will write negative 2 over square root x, ln x first, with limits 1 to 4, minus integrate from 1 to 4 v du, right? So negative 2 over square root x times 1 over x dx. Then now, when you replace the x by 4 first, for the first part, I will get negative 2 over square root 4 ln 4 minus negative 2 over square root 1 ln 1. Now, the next step is these two minus group together, it will be plus. Minus minus is a plus, and then I will factorize the 2. So for the denominator, this is x degree half, here is x degree 1. So x degree half times x degree 1, that is basically x degree 1 plus half. Then I will be getting x degree 3 over 2. Okay, so I will just write this, but then since both also the denominator, that means you have to times the negative. So x power negative 3 over 2 dx. And it is from 1 to 4. So now, for the first one, square root 4 is 2, so minus 2 over 2, that is minus 1, so minus ln 4. So then, for the next term, ln 1 is basically 0. Alright, so now my next term is going to be plus 2 integrate x power negative 3 over 2. So again, Negative 3 over 2, this integration already done. That is our v. So I will just rewrite this. So that is going to be negative 2 over square root x from 1 to 4 limits. Okay, now when look at the question here, ln 4, therefore I will keep the minus ln 4. I just need to prove the 2 from the second part or from the second term. So then from here, I will rewrite the negative ln 4 and the minus 2, this minus 2 combined with the 2, that is minus 4. So 1 over square root 4 minus 1 over square root 1, that is 1. So at last, I will be getting minus ln 4 minus 4 times square root 4 is 2. So this is half minus 1. So half minus 1 is basically minus half. So minus half times the minus 4, that is going to be positive 2. Okay, since now we need to prove this form 2 minus ln 4, so better rearrange. So this is going to be 2 minus ln 4. So done for the question. Okay, so for question number 5, given the variables sin y equals to tangent x, where the y is defined from minus pi, half pi, and half pi, show this dy dx. So now, sin y equals to tangent x. So now we need to get dy dx from the sin y, means that we need to apply the chain rule. So differentiate function of y with respect to x. That is to differentiate function of y with respect to y, then you times by dy over dx. Okay, so which means now here, differentiate sin y, that is cos y, then times by dy dx, and differentiate tangent is basically secant square x. By looking at this answer, we need to change to cos x and cos 2x. Right? So, which means now this secant square x is basically 1 over cos square x. And now I can just move down the cos y to get my dy dx. So my dy dx is 1 over cos square x times 1 over cos y. Okay, now cos square x, okay, so then from here, I have cos y, alright, and then now you are given sin y, the answer without the y, and now I am getting cos y in my answer. Therefore, I need to use this sin y equals to tangent x to solve the cos y. So what to do is you just draw a right angle triangle. Let's say this is y. So we know that sin y is opposite over adjacent. So that means sin y equals to tangent x. So sin y equals to tangent x. That means the opposite side of the y is tangent x. Because the tangent x is same as tangent x over 1. So this is tangent x. And then the adjacent side is 1. So the hypotenuse here, sine is opposite over hypotenuse. Okay, sine y is opposite over hypotenuse. So opposite is tangent x, hypotenuse is 1. So it means that the adjacent side is going to be square root of 1 minus tangent x squared, according to the Pythagoras theorem. So this is same as square root of 1 minus tangent square x. Right? So now here I will change. So this is 1 over cos square x. After that, 1 over the cos y. Cos y is basically adjacent over hypotenuse. So that is square root 1 minus tangent square x divided by 1. So then from here, you will get 1 over cos square x. Okay, so because of 1 over square root, this is actually 1 over square root 1 minus tangent squared. So I will just combine with the left side. So I will rewrite this first. Then next time I'm going to combine, because you can just times together. It will be cos square x, then multiply with the square root. Okay, now here we need to get square root cos 2x. So I already found the square root here. So what to do is the tangent squared you change to sine and cos, right? So 1 over cos square x square root of 1 minus sine square x over cos square x. Then this is going to be 1 over cos square x, then square root of, get the same denominator, that is cos square x minus sine square x over cos square x. Then now, the square root of cos square x, basically you can just move up, or if not, you can just leave it, and then I will simplify. It will be 1 over cos square x. Then for the square root, okay, we have a formula. Square root of a over b is basically square root a over square root b. So now you can split it into two square roots. It will be square root of cos square x minus sine square x over square root of cos square x. So the square root of cos square x is basically cos x. Okay, so here is basically cos x. So then there is a cos square x here. That means this cos x and the cos square x can be cancelled off. Therefore, I will be getting the answer as 1 over cos x square root of, now from the identity, cos 2a is cos squared a minus sine squared a. That means now the cos square x minus sine square x is basically cos 2x. So this is cos 2x. Okay, so we have proven this form. Okay, now question number 6. The variables x and y satisfy the differential equation where k equals to a constant, given that x equals to 0, y equals to 1, and x equals to 1, y equals to square root e. Solve the differential equation, obtaining the expression for y in terms of x. So now, dy dx equals to ky cubed e negative x. So now the dy is in the numerator, therefore I will keep all the y on left side. So the y cube, when you move it to the left side, it will be y degree negative 3. And then the rest, the k is a constant, then I can just keep it on the right side and move up the dx. So once you have splitted the variables, you need to integrate both sides. Okay, so now when you integrate y degree n, okay, same as just now, this is going to be y degree n plus 1 over n plus 1, then plus c. So that means now you are getting y degree minus 2 over negative 2. For the right side, to integrate the exponential function, you need to rewrite the whole exponential function and differentiate the power of e, that is a. After that, plus c. So which means now here I will be getting k e power negative x over negative 1, then plus c. Okay, so now I will rearrange now. The power of negative 2 for the y, I will move it down. Therefore, you will be getting negative 1 over 2y squared. Then the minus 1 combined with the k, that will be minus k. The e power negative x, you can just rewrite, and plus c. Okay, now simplify. X equals to 0, y equals to 1. This is to get the c. So when x equals to 0, your y is 1. That means you will be getting negative 1 over 2. Because the y is 1, no need to write. Then equals to negative k e power negative 0 plus c. So e power 0 is 1. Therefore, e power negative 0 is also 1. I'm getting the first equation, that is negative half equals to negative k plus c. Because now we need to find k and c. Now the second equation, x is 1, y is square root x, y is square root e. Then again substitute into this equation, I will be getting negative 1 over 2 square root e, that is my y, then you square it, equals to negative k e, the x is minus, the x is 1, then plus c. So now, the square of square root e, that is e. Therefore, I will be getting negative 1 over 2e equals to negative k e power negative 1 plus c. That is my second equation. So to solve these two equations, I will use the first equation minus the second equation to eliminate the c, because both also plus c. So first minus second, I will be getting negative half minus 1 over 2e, that is plus 1 over 2e, then equals to minus k minus k e power negative 1, that is plus k e power negative 1. Then now to get the k here, I will simplify the left and right side. Okay, so left side I will make it to 2e for the denominator, which means the first term I need to times by minus e. So my numerator now becomes negative e plus 1. Then for the right side, I will factorize the k. So once I factorize the k, I get negative e plus negative 1 plus 1 over e. Okay, then now again I will simplify the right side first to get the same denominator. So I make it to over e. That will be negative e plus 1. So I will rewrite my left hand side. And now the e can be cancelled off from both sides. Okay, and then we can get the k. So the k is basically this term, okay, this numerator move down, because at first it's times. When you move down, when you move it to the other side, it becomes divide. So I will get my k as, okay, basically before you move down, right, I didn't realize that. Okay, I just aware about that. Now from here, both numerators are the same, therefore I can cancel off. Okay, so now I can get my k equals to, once you cancel off, this is left 1, so my k is half. That is my k value. Okay, now here to get the c, you can just substitute into the first or second equation. Obviously the first equation is easier, so I will just refer to first equation. Minus half is minus k plus c. So minus k plus c. Therefore, my c equals to 0, because both sides you have minus half. So after this, substitute these two values, k and c, in this solution. This is our solution. Okay, so minus 1 over 2y squared equals to negative k e negative half x. So negative half e negative x plus c. C is 0. Then now, look at the question. You need to get y in terms of x. Then now here, the easiest way is, see, both sides has negative half, right? Here is negative, and then this is over 2, right? So that means I can just simplify this. Or probably if you want, you can just write times negative 2. Okay, so times negative 2. Therefore, you will be getting 1 over y squared equals to e negative x. So e negative x is actually 1 over x. So 1 over y squared is 1 over ex. Therefore, from here, my y squared is ex. And now the question is asking for y and not y squared. Okay, therefore, my y is going to be just plus minus square root. So my y is plus minus square root of ex. You can leave your answer in this form, or probably the square root is basically degree half. So ex degree half, that is e half x. You can leave your answer in this form. That is your y. Okay, then now let's see. Just obtain an expression for y in terms of x. That's it for the answer. Okay, now here we have to check whether we can accept both or not. Now you check when x equals to 1. Okay, it's given here. When x equals to 1, y is square root e. So because of this square root e, I know that I shouldn't accept plus minus. Okay, so because here I get y equals to plus minus once I simplify the square. So now given x equals to 1, y is square root e, that means now impossible to accept the negative, right? So because when you look at here, your x is 1, your y is plus minus square root e already. So therefore, my final answer, it should be just e degree half x, or probably you can just write square root ex, up to you. Okay. Seven A, showing all working and without using calculator. Solve this quadratic equation. Give your answers in the form x plus iy, where x and y are real. Okay, so now 1 plus I times z squared minus 4 plus 3i z plus 5 plus I equals to 0. Then from here, this is a quadratic equation, right? I will let the z be x plus iy. So let's later. So now my coefficient for z squared is 1 plus I. Then the coefficient for z is negative of 4 plus 3i. Then the c is 5 plus I. So now, since your equation in terms of z, that means when you solve, that is a z. That will be formula, okay, ax squared plus bx plus c equals to 0. Again, your x is minus b plus minus square root of b squared minus 4ac over 2a. So now I will be getting minus b. So minus minus is a positive. I will just ignore that negative sign. I'll write 4 plus 3i. Then plus minus square root of b squared. So when you square the negative, it will be positive. Minus 4, a is 1 plus I, c is 5 plus I. Then over 2 times 1 plus I. That means from here, I will be getting 4 plus 3i plus minus square root of, okay, so here you have to do expansion. The first one, you have to use the quadratic expansion. A plus b squared, that is going to be a squared plus 2ab plus b squared. So I will be getting 4 squared is 16. 4 times 3i times 2, then you will be getting 24i. Okay, after that, plus 9i squared. Then now here, minus 4. Then for the bracket here, just do expansion. Right? So 1 times 5 is 5. I will just write 5. Then 1 times I and the 5i together will be 6i. Then I times I squared over 2 times 1 plus I. Okay, now here I will be getting 4 plus 3i. You need to simplify right now. So square root of, when I do expansion, this is 20. So 16 minus 20, that is minus 4. Okay, then 24i, look at here, 24i, this expansion is negative 24i. That means you get 0. After that, 9i squared minus 4i squared, that is 5i squared. Okay, so now here I will be getting these two terms and rewrite the denominator. Now we know that I squared is basically minus 1. So if I replace this I squared by minus 1, that means you are getting minus 4 plus minus 5. That is minus 9. Then I will be getting 4 plus 3i plus minus square root of minus 9. Then over 2 times 1 plus I. Okay, square root negative 1 is I. Right, so square root negative 1 is I. That means square root minus 9 is basically square root negative 1 times square root 9. So square root 9 is 3. Square root negative 1 is I. Therefore, I'm getting 3i. So you will be getting 4 plus 3i, then plus minus 3i over 2 times 1 plus I. So now, I will calculate using the minus first. That means 3i minus 3i. Right, you split it into two parts. So this will be my z value. But then later we still need to simplify. This will be my z. So now for the first one, it will be 4 over 2 brackets 1 plus I. And then the second one, it will be 4 plus 6i over 2 brackets 1 plus I. Okay, so now for the 4 plus 6i, basically I can just simplify. Okay, so even for the first one, I also can simplify. 4 over 2 is 2, so I'm getting 2 over 1 plus I. And then to simplify this, since you need to get your answer in x plus iy here, that means you need to eliminate the denominator, the I in the denominator. So I need to times the conjugate. So the conjugate is 1 minus I. So same goes to the right side, the next value. So the 2 and 4 can be simplified, becomes 2, and then the 6 divided by 2 is actually 3. So I'm getting 2 plus 3i over 1 plus I. Then here I multiply with 1 minus I and 1 minus I. Okay, then now here simplify. For the denominator, we have one formula. A plus bi times the conjugate, that is going to be real squared plus imaginary squared. Therefore, I will be getting 1 squared plus 1 squared, then the 2 you multiply. So I will be getting 2 of 1 minus I, and same goes to the next calculation, that is also 1 squared plus 1 squared. Now here just do expansion, right? So 2 times 1 minus I, that is going to be 2 minus 2i. Then 3i times 1 minus I, that is plus 3i minus 3i squared. Then now for the first value, I'm getting 2 for the denominator, and for the second value, I will be getting, now remember this I squared is minus 1. So that means 2 minus 3 times minus 1, that means it's 2 plus 3, that is 5. Then minus 2i plus 3i, that is plus 1i. Okay, so from here, the 2 can be cancelled off from both numerator and denominator. Therefore, I will be getting 1 minus I, and the other one we can solve. So you can split, because in the question it's mentioned that it must be x plus iy. So now I have to write the real part as 5 minus 2, 5 over 2, and then plus imaginary part is basically 1 over 2. Then this will be my solution. B. The complex number u is given by u equals to minus 1 minus I. On a sketch of an Argand diagram, show the points representing u. Shade the region whose points represent complex numbers satisfying these two inequalities. Okay, so now here the first one, this is same as modulus of z minus 0 plus 0i. This is going to be the, if it is equal sign, means that will be the perpendicular bisector. So 0 plus 2i. Right, so here I'm getting 2 points. Points with coordinates 0, 0, because it's 0, 0i, and then the other one is 0, 2. Now, for the next one, it's going to be 1 over 4 pi, the argument z minus u. The u is minus 1 minus I, in between half pi and 1 over 4 pi. Okay, so now I will sketch. Your u is minus 1 minus 1. Therefore, say here minus 1. This is minus 1. And then points we need 0, 2. So here 1, this is 2. This is real axis. This is the vertical is an imaginary axis, and then this is real axis. Okay, here is 0. Now I get this first, so my u is basically with coordinates minus 1 minus 1. That means it's over here. This is my u. Alright, so then the question says, on the sketch show the point, just point, done for the point. And now here, you refer to this u as a point, reference point, and mark the angles, half pi and 1/4 pi. So if you treat this as the reference line, okay, so now your half pi is basically 90 degrees. So here is my half pi. And there is no equal sign for both inequality. So I should use the dotted line. Here is 90 degrees. And 45 degrees, okay, this is 45 degrees, means when x is minus 1, the y is minus 1. When x is 0, y is 0. So that means your angle here is going to be pi/4. Alright, so now my angle, my region will be bounded by these two dotted lines, means here. And now I have to check the points. So for the points, 0, 0 and 0, 2. 0, 0 here. Oh, 0, 2 is actually the y value. It's not the 2 is a y value, it's not the x. Here. These are the 2 points. And now, I need to find out a point for the z, general point, so that the distance from the general points to the origin is less than the distance from the general points to 0, 2. So let's say I take here as the z. So obviously the distance from this, right? So when it is equal sign, right, I will say when it is equal sign, that means it will be here, right? This is equal sign, but then it is less. So it means that now you have to check where is your point. Your point is above the green line or below the green line, which is 1 here. So if I take below the green line as a z, the distance from this point to the origin, okay, is so short. Obviously it is shorter or smaller than the distance from the point, this point, to 0, 2. So that satisfies this equation. That means now my point, my z, should be below this dotted line 1. Okay, so which means now I will have to combine these two conditions, which means it's bounded by these two orange line and also the green line. So your region is over here. Okay, so done for the solution. Question 8. Given the fx, express fx in partial fractions. So 12 plus 12x minus 4x squared over 2 plus x multiplied with 3 minus 2x. Okay, so before we do the partial fractions, we have to check whether you are given the proper or improper rational function. So basically, when you do expansion for the denominator, it is a quadratic, which means x squared. And the numerator also x squared, which means now we need to perform polynomial division before the partial fractions. So it means that now I have to do the expansion for the denominator. So 12 plus 12x minus 4x squared. For the numerator, denominator, when you do expansion, 2 times 3 is 6. 2 times minus 2x is minus 4x. Minus 4x together with this 3x, that will be minus 1x. Then the x times minus 2x is minus 2x squared. And now here, we need to perform the polynomial division based on this form. Now, my polynomial division, I will just show over here. Or probably I'll show here. That is negative 4x squared plus 12x plus 12 divided by negative 2x squared minus x plus 6. Okay, so to get negative 4x squared from negative 2x squared means that we need to multiply with 2. Therefore, 2 times negative 2x squared is negative 4x squared. Then 2 times minus x is negative 2x. Sorry, the 2 should be at the back. Then 2 times plus 6, it will be plus 12. Okay, so then when you minus, first term will be 0. Second term is 12x minus 2x, that is 14x. So I will say that this is basically 2 plus 14x. We stop here because the x degree 1 in the remainder and the divisor is degree 2. So as long as the degree in the remainder is less than the divisor, then we stop the polynomial division. And then the denominator, I will rewrite these two factors. And now my partial fractions will base on the latest function here. Okay, latest rational function. Then later I will combine with the 2. So now from here, I will start with 14x over 2 plus x multiplied with 3 minus 2x. Now since the denominator has 2 linear factors, then it will be a over 2 plus x plus b over 3 minus 2x. Then now here, you will get the same denominator. So I will always get the same denominator as in the left hand side. So which means for the first term, I have 2 plus x, so I need to multiply with 3 minus x for both numerator and denominator. Same goes to the second term. Oh, 3 minus 2x. Sorry, there is a mistake. This is 2x. So for the second term, b over 3 minus 2x, so you multiply with 2 plus x, then over 2 plus x. Okay, then from now here, since you are getting the same denominators, which means we can just cancel off the denominators and compare the numerators, which means now I will be getting 14x equals to a times 3 minus 2x plus b times 2 plus x. Okay, so now to get the a and b, just let the factor be 0. So the first factor is 3 minus 2x. I let this be 0. That means my x is going to be 3 over 2. So then 14 times 3 over 2, as long as you see 3 minus 2x, that will be 0. Then I will be getting b times 2 plus 3 over 2. That means now here, you will be getting 21 equals to 7 over 2b. Therefore, your b is going to be 6. Okay, now next is let 2 plus x be 0. That means the x is going to be negative 2. So now the left hand side, it will be 14 times negative 2 equals to a bracket 3 minus 2 times negative 2. So that means now here, you will be getting negative 28 equals to 7a. Okay, therefore, your a will be negative 4. So once you have found these two values, a and b, substitute back into this final answer. Alright, so I will write my fx is basically 2 plus. Now my a is minus 4. So when you substitute into here, the plus and minus becomes minus. So I will get minus 4 over 2 plus x. So here it will be minus 4 over 2 plus x. And same goes to the b. The b is plus 6. So here plus 6 over 3 minus 2x. Okay, so done for this part. Alright, so now next part 2. Hence, obtain the function expansion of fx in ascending powers of x up to and including the term in x squared. Right, now fx, just rewrite 2 minus 4 over 2 plus x plus 6 over 3 minus 2x. Okay, so now to do the expansion, move up the denominator. So it will be 4 bracket 2 plus x degree minus 1 plus 6 bracket 3 minus 2x degree minus 1. And now for the binomial expansion, since the degree is minus 1, so we are going to use this formula. That is going to be 1 plus nx plus n minus 1 over 2 factorial x squared. Okay, because here up to x squared. So I will stop here. And then it's going to be 2 minus 4. Now when you use this formula, it must be you have to make sure it is 1 and plus. So the x can be plus or minus, no problem. Alright, so here, since you are given 2, therefore I will factorize the 2. You will be getting 1 plus x over 2, degree minus 1. And plus 6, the 3 will be taken out. You will get 1 minus 2 over 3x, degree of minus 1. Then this is going to be 2 minus. Now, this power negative 1, you have to move in. Okay, so bring it in because we have a formula AB degree m, that is A degree m, B degree m. So then you will be getting 4 times 2 power negative 1, that is half. After that, followed by the expansion using this formula. So 1 plus n, x is x over 2. Okay, after that, plus minus 1 minus 2, because n minus 1 becomes minus 2, over 2 factorial, that x over 2 squared. That is the first expansion, followed by plus 6. The power negative 1 for the 3 is basically 1 over 3. Then 1 plus nx. After that, followed by minus 1 minus 2 over 2 factorial. Then negative 2 over 3x squared. Okay, so then from here, you will be getting 2 minus 4 times half is 2. Then the first term rewrite minus 1, plus times minus 1 times x over 2 is negative x over 2. Then followed by the minus 1 minus 2 over 2 factorial is basically 1. Okay, so you can cancel off this and make it to 1. This is 1. Here is also 1. That means you are getting x squared over 4. So for the last expansion, 6 times 1 over 3 is 2. Then the terms inside the brackets will be 1 plus 2 over 3x plus 4 over 9x squared. Then now just open all the brackets. You will be getting 2 minus 2. So this minus 2, bring it in. It will be plus x. Then minus 1 over 2x squared. These two, again multiply in. You will be getting plus 2 plus 4 over 3x plus 8 over 9x squared. Okay, so now simplify all the constants. So the first two terms will be cancelled off. Left the 2. So I will be getting 2. The x here combined with other x. So here plus x plus 4 over 3x. You will get plus 7 over 3x. Then for the x squared, just simplify the remaining terms. So negative half x squared plus 8 over 9x squared, that is 7 over 18x squared. So that is the expansion of the fx up to x squared. Okay, question number 9. Two planes have equations, right? Find the acute angle between the planes. So now this plane equation has been moved to further maths. Okay, so anyway, I will just solve it. So now for the first equation, 2x plus 3y minus z equals to 1. Now you can change to r dot, because the general form is r dot n equals to a dot n. So the n is basically 2, 3 minus 1. That equals to 1. That means from here, my n1, because you are given two planes, it will be 2, 3 minus 1. Now for the second line, or second equation, then from here I will write r dot 1x minus 2y, 1z equals to 3. Therefore, my n2 is going to be 1, negative 2, 1. Now, for the acute angle between two planes, so let theta be the angle between two planes. Okay, so basically it's like this. This is your n1 or pi 1. This is your pi 2. So for the n1, for the pi 1, we will have n1, which is perpendicular to the n1, to the pi 1. This is n1. And then for the pi 2, I will have the normal vector. This is your n2. Okay, here is 90 degrees. So I'm finding angle between two planes, which is here. Okay, but then I'm counting n1 and n2 angle. I'm finding this alpha. Right? Oh, basically from here you should understand that theta equals to alpha, because we know that this is 90 degrees, here is 90. Okay, that means this value is pi over 2 minus alpha. But when you refer to this part, here is also 90 degrees, which means pi over 2 minus alpha plus theta equals to pi over 2. So pi over 2 will be cancelled off, therefore theta equals to alpha. Right? That's why I would say that the angle between two ends is same as angle between two planes. Right? So then from here, I will just direct find what is the theta. The theta is actually angle between two planes and also angle between two ends. Right? So use the formula n1 dot n2 equals to magnitude n1 magnitude n2 cos theta. So now when you do the dot product, actually we are multiplying the corresponding elements. So 2 times, not elements, components. 2 times 1 plus 3 times minus 2. Okay, plus minus 1 times 1 equals to square root of 2 square plus 3 square plus minus 1 squared, then square root of 1 square plus minus 2 square plus 1 squared, followed by cos theta. Okay, then from here, the left hand side is going to be minus 5. Now for the first square root, that is square root 14. Then the second square root is square root 6, followed by cos theta. Then from here, your cos theta is a negative value. That means it is not acute angle, it is obtuse angle. So now I will be getting 123.06 degrees. Now which means you have found this part. Okay, 23.06 degrees. That is your angle. And now you need to find here. So obviously that is 180 minus the value that we have just counted. Acute angle equals to 180 minus 123.06 degrees. Then that is going to be 56.94. And now, remember, the angle in degrees must be one decimal place. Therefore, 56.9 degrees. So that's the solution for this part. Okay, part 2. Find the vector equation for the line of intersection of the planes. So for intersection of the planes means that we just solve the plane equations, right? So I will rewrite these two equations and solve the simultaneous equations. So when we solve this, obviously I can eliminate the z because one is minus z, one is plus z. So first plus second equation to eliminate the z. So I will get 3x, 3y plus minus 2y. That is plus y. Right side is 4. So from here, I know that my y equals to 4 minus 3x. So you should realize that there are 3 variables, x, y, z, but only 2 equations. So we will always get infinite solution, okay, because of not enough equations there. So since I have found that my y depends on x, excuse me. So I will let my x be a parameter because it can be any numbers. So my y, it will be 4 minus 3t. Then with these two x and y, I can just substitute into the second equation to find another unknown, which is a z. Okay, so from second equation, you can substitute into first equation, no problem. So my z is going to be, just move the two terms on the left side to the right side. So it will be 3 minus x plus 2y. So now replace x and y. So 3 minus t plus 2 of the y is 4 minus 3t. Then open the brackets, you will get 3 minus t plus 8 minus 6t. That means now here you will be getting 11 minus 7t. Okay, so just combine all the results. So here, you write your x, y, z vertically in vector form. So my x is basically t. Okay, refer to all these three results. So here I will write t. So x is 1t. Your y is 4 minus 0t. So it's 4 minus 3t. So means that 4 then minus 3t. Then my z is 11 minus 7t. This is minus 7. So from here, I'm getting the vector equation. So done for this part. So you can write r equals to 0, 4, 11 plus t of 1 minus 3 minus 7. So that is the solution for part 2. Okay, so for question number 10, the diagram shows the graph y equals to sine cube x times square root of cos x for x between 0 and half pi, and the maximum point m. Now first part, using the substitution u equals to cos x, find by integration the exact area of the shaded region bounded by the curve and the x-axis. Okay, so now basically the area area equals to integrate from 0 to half pi the function sine cube x times square root cos x dx. Because our formula is integrate y dx. Okay, all your regions towards the x-axis. And given the hint u equals to cos x, so now here I will just write u equals to cos x. I need to find dx, right? So du, or probably du over dx is negative sine x. Therefore, your du equals to negative sine x dx. Right. So now, in other words, sine x dx is minus du. So it means that instead of sine cube x, I have to split it into sine square x and sine x. Then the sine x combined with the dx to be changed to negative du. And then now I need to calculate the limits. So when x equals to 0, my u is cos 0. That is 1. Then my x equals to half pi. My u is cos half pi, which is 0. That means now my area is basically, I change to the form first. Instead of sine cube x, I change to sine square x, then sine x, square root cos x dx. Okay, so now this sine x dx will be changed to minus du. This cos x will be changed to u. And then here we have sine square x. So now I have to use another identity. Sine square x plus cos square x is 1. Therefore, sine square x is 1 minus cos square x. That is going to be integrate 0 to half pi. This is 1 minus cos square x. Then sine x square root cos x dx. Okay, so with this, I will change all into u now. So 1 minus cos square x is basically 1 minus u squared. Now, remember, just now I said sine x dx is negative du. So I will write negative du. Okay, then the square root cos x is square root u. So you are getting this now. Now the negative can be taken out. So negative, integrate 0. Okay, the limits must change accordingly. So no more 0 to half pi. So because when x is 0, your u is 1. When x is half pi, your u is 0. Okay, so 1 to 0. Then this is u degree half. You multiply with 1. That is going to be u degree half. Then minus, because this negative already taken out. Okay, so u degree half times u squared. U degree half times u squared. That is u degree 2 plus half, or half plus 2. That is u degree 5 over 2. So I will write u degree 5 over 2. Okay, so then from here, negative, whenever you integrate, refer to this formula, integrate u degree n d x degree n. Let's say I use x degree n dx. That is x degree n plus 1 over n plus 1 followed by plus c. If with limits, no need plus c. Alright, so here is going to be u degree 3 over 2. You divide by, supposedly divide by 3 over 2. So you divide by 3 over 2 is same as you times 2 over 3. Then minus u degree 5 over 2, you plus 1, that is 7 over 2. Then divide by 7, 2, that is times 2 over 7. And now here you just replace the u by 0 first. So everything is 0. Minus, when the u is replaced by 1, you will get 2 over 3 minus 2 over 7. Then from here, right, you will be getting negative of 8 over 21, the negative. Therefore, at last, 8 over 21. This is your exact area. Okay, part 2. Showing all your working, find the x-coordinate of m, giving your answer correct to 3 decimal places. So it's mentioned that the maximum point m. That means now I need to find x-coordinate of the maximum point. That means we have to differentiate. Okay, so now rewrite this function first. Y equals to sine cube x times square root cos x. So I need to differentiate, and there are two terms here. Therefore, we need to apply products rule. That is uv prime plus vu prime. So now my first term, my u, okay, so here my u is basically sine cube x. This sine cube x is same as cube of sine x. Now when you differentiate this, so I will get differentiate fx degree n. that is n times fx, degree n minus 1, then you multiply with f prime x. So here is going to be u prime equals to 3 sine x squared, then differentiate sine x cos x. That means I will be getting 3 sine square x cos x. That is my u prime. My v is square root cos x. This square root cos x is basically cos x degree half. So again, use this power rule. So v prime is basically half cos x. So half minus 1, that is negative half. And then differential cos x is minus sine x. So from here, since the cos x with degree negative half, I will bring it down. That means it will be negative sine x over 2 square root cos x. Okay, now apply the products rule, d over dx uv. So now I will be getting my dy dx. Okay, that is u v prime. So sine x, sine cube x, I will write sine cube x multiplied with negative sine x over 2 square root cos x. That's my uv prime plus vu prime. So this is square root cos x. V prime is this, multiplied with 3 sine square x cos x. Okay, so now we need to find the x coordinate. X coordinate happens when dy dx equals to 0. But before that, I need to factorize the common term. Okay, so when you look at here, for the denominator, here we have 2 square root x. This must be 2 square root cos x. This must be factorized out. And then for the numerator, here I have sine square x. Okay, even though this first term is sine degree 4. So these are the two common terms, right? So which means I have to factorize over 2 cos, or I will factorize sine square x over 2 square root cos x. So once I factorize 2 over 2 square root cos x, the numerator also sine square x. That means you still have minus sine square x, because initially you get minus sine degree 4x. Okay, plus when you factorize 2 square root cos x from cos x here, basically you should have 2 square root 2 cos x. Okay, because cos x over square root cos x is square root cos x, and then the 2 over 2 will be 1. So instead of square root cos x, I will change to cos x, right? Then here multiply with 3 cos x. Then here you will be getting sine square x over 2 square root cos x, then minus sine square x. Here you just do expansion, that is plus 6 cos square x. Okay, once you get this, I will write as m dy dx equals to 0. So when dy dx equals to 0 means that either the first term equals to 0, or the bracket equals to 0. Alright, so now when the first term equals to 0, numerator equals to 0. Sine square x equals to 0. That means your sine x equals to 0. Then now, look at the graph. Okay, the x is defined from 0 to half pi. And then obviously the m is not 0 because it is on the right side of 0. So when sine x equals to 0, now you refer to the sine graph. That means it will be at 0, pi, and 2 pi. Okay, so your x will be 0, pi, 2 pi. So given now your x is from 0 to half pi. Okay, so let's check one more time. Here, 0 to half pi. And then obviously the m is not 0. So that means no solution. Okay, so no solution here. Alright, so then I have to solve the second equation, which means now my 6 cos square x equals to sine square x. So divide the whole equation by cos square x. Then you will get tangent square x, because sine square x over cos square x is tangent square x, that equals to 6. So now tangent x will be plus minus square root 6. Okay, so then now because the x is given, it is in the first quadrant 0 to half pi. That means now your tangent x is going to be positive value. So then you can just use a calculator. X is inverse tangent square root 6, and then that is going to be 1.183. Let's go back to the instruction of the question. 3 decimal places. Okay, so that is your x value. That means the x coordinate of m equals to 1.183. So that's the solution of this question. Okay, so I have completed this paper and also comes to the end of the video. Thanks for watching. Please subscribe to the channel if you enjoy watching the video, and share this channel with your friends. Okay, and also stay tuned for more upcoming videos. Thank you everyone. Bye.